Good afternoon, everybody, and welcome to NET313, where we'll be talking about some encryption in transit today. My name is Scott Morrison. I'm a networking SA here at AWS. This will be my, I think, 5th reInvent that I've presented at, and my 7th year at AWS. And I'll say that after 7 years at AWS, I've gotten to know a lot about how our network operates under the hood, where all the packets are going through our network, what's happening to them. And it's lost a little bit of the mystery after 7 years. But then I come to reInvent and I get to meet with all of our great customers and see the mystery that still happens of how the network works at AWS. And so today we're gonna unwrap a little bit of that mystery for you, talk about how some of that encryption works at AWS on our network, and some great new features related to VPC encryption controls. So with that, I'm going to bring on my peer and a product manager for VPC, Akshay Chowdhury, to take it over and talk a little bit about VPC encryption controls, and then I'll be back with you here in a few minutes to talk more about encryption. Akshay?
Good afternoon, everyone. My name is Akshay Chowdhury. I lead the product management team here at AWS for VPC. So here I'll first introduce encryption. I'll talk about what is encryption, how do you implement it, how it has evolved over the time, and then I'll talk about the challenges in implementing encryption. And with that, I'll talk about how AWS is solving many of those challenges by offering native encryption across multiple network paths. And after that, I'll introduce this new feature, VPC encryption controls. We launched it 2 weeks back. This feature helps you monitor the encryption status of your traffic flows, and it also helps you identify workloads that are not enforcing encryption, and it offers you tools to enforce encryption in transit across your environment in a region. A lot has gone into building this feature, and we would love for you folks to go back and try your hand at this feature and give us feedback. One thing that is common across all the successful features at AWS is that we got a lot of feedback from our customers about what they expect from these features, and then we kept working on those feedback and we improved it over time, and we would really appreciate your support in doing the same with VPC encryption controls. And after I've discussed the details of how to set up VPC encryption controls and what it does, I'll hand over the stage to my co-presenter Scott, who will discuss encryption strategies and the emerging encryption frontiers. So, with that, encryption. What is encryption? Encryption is the process by which you protect your data from getting snooped on or from getting compromised by scrambling it using some logic. So in this example, suppose the sender wants to send a simple text, "Welcome to reInvent." So what they would do is they would use some logic to scramble it with the expectation that only the intended receiver can unscramble it and look at the original message. This way, someone who's not intended to see this message will never see the original text. So encryption has been known to exist since 100 BC. Back then it was used for secure communications between military factions, and it was called Caesar cipher. It used to be pretty simple back then. It used to consist of some alphabetic substitutions. With time, the attackers got more sophisticated, and they knew how to decipher the simple encryption. And with that, the encryption also evolved to make it more difficult for any attackers to decipher it. So we have evidence that around 15th century, the encryption consisted of polyalphabetic substitutions. And then in World War II, Germany came out with the Enigma machine to encrypt all their communication. And back then, it was considered unbreakable, until Alan Turing developed a machine to decipher those or to break that encryption. And that machine was the first computer. That led to the invention of the first computer. But until now, there was no one set standard worldwide for encryption. But in 1977, there were there were encryption standards that were used worldwide, and those were DES, or which is Digital Encryption Standard, and RSA. And today, the most prominently used encryption standard is Advanced Encryption Standard. You may have heard of AES, that's Advanced Encryption Standard, and it comes with different key lengths, and we'll discuss about these things later. And today, the post quantum cryptography is also picking up. Scott will talk more about it. But post quantum cryptography is considered to be safe even from attackers who use quantum computers to break it. With that, let's look at how encryption works. We are looking at the old example that we looked, where a sender wants to send this simple text, "Welcome to reInvent." What the sender does is, before sending this message out, the sender will use a cryptographic mathematical model to derive a key using which they would encrypt this or scramble this text. Once they've scrambled it, they use the same mathematical model to derive another complementary key that can be used to unscramble or decrypt it. And let's call that the receiver key. Once they have that complementary key, they find a way to securely transmit that key to the receiver. When the receiver receives the key, they are able to decrypt the traffic and look at the original message. Now, when the sender key and the receiver key are different, it's called asymmetric encryption. And when they're same, it's called symmetric encryption. Worldwide, the most common encryption standard uses symmetric encryption today. Now, you may have noticed two things here. One is that it takes some computational power, both on the sender side and the receiver side, to encrypt and decrypt the traffic. Along with that, the security of the key is of paramount importance here. Because God forbid, if this key gets into the hand of an attacker, they will have visibility into the entire communication between the sender and the receiver. That's why companies spend large amount of resources to build infrastructure that can keep these keys secure and that can rotate these keys regularly, so that in case of a compromise, the blast radius is limited. So AWS, long back itself, AWS had recognized the challenges in implementing encryption and building these secure key management systems. And we started offering native encryption across multiple paths. So next we'll discuss the native encryption that AWS offers across different paths. So today, all your traffic between any two AWS data centers is encrypted using state-of-the-art advanced encryption standard with a 256-bit key. Whenever this traffic leaves AWS secured facilities. And this encryption is implemented between data centers in an availability zone, across availability zone, and even across regions. And when the traffic is transmitted between regions, if you're using transit gateway peering or if you're using cross-region peering, then all the traffic gets an additional layer of bulk encryption on top of the native AES 256 encryption. So and you may have noticed that I've been saying that this traffic is encrypted when it leaves the AWS secured facilities, and these facilities are really secure because there's physical security present there, and no unauthorized personnel can just walk into these buildings. But there's no such thing as more security. So back in 2019, we launched Nitro encryption or VPC encryption, and what that is that today any two modern EC2 instances, when they're communicating with each other, all the traffic between these instances are encrypted using state-of-the-art AES 256 encryption. And this encryption holds true even within your data centers, even within AWS secured facilities. So I still remember back in 2019 when we launched Nitro encryption. Back then there were hordes of customers who upgraded their entire infrastructure so that they can use this native Nitro encryption. The good thing about this Nitro encryption is it's transparent to the customer. No, you don't have to manage the key infrastructure. It does not impact the compute power or the processing power of your compute or your EC2 instances, and it just works there transparently. So even today, a lot of customers manage Excel workbooks where they track the usage of instance types across their environment. But tracking it manually has a couple of challenges. One is, of course, it's a manual effort to track the instance usage across your environment. The other thing is this encryption, this native Nitro encryption, works on modern EC2 instances, but your EC2 instances also communicate with AWS services or external services, not many of which not all of which support Nitro encryption. The other problem is that as you introduce new workloads, the number of potential network paths increases exponentially. And then tracking and monitoring encryption across all these network paths, it can get really difficult real quick. That's why AWS launched VPC encryption controls 2 weeks back to address these challenges. So VPC encryption controls it comes in two modes. One is the monitor mode, the other is the enforce mode. It allows you to monitor the encryption status of your traffic flows. It also allows you to identify resources that are not enforcing encryption in transit. And then it gives you the tools to enforce encryption in transit within your VPC and even across your VPCs. And once you have done that, you can also generate flow logs for auditing purposes, or you can also look at what VPCs are enforcing encryption and what VPCs are not enforcing encryption. And this feature is really easy to use. We'll cover it up in the subsequent slides. You can literally click a single button and you can turn on encryption controls in your existing VPCs or your new VPCs. You can turn it on during creation itself. And other thing is it addresses the other challenge, and it offers native Nitro encryption beyond EC2 instances to many AWS services like RDS, Redshift, application load balancer, Fargate tasks, etc. It also works across your VPCs whenever you're using VPC pairing or whenever you're using transit gateway. And you can exert all these controls centrally, and you can create reports, and you can show that you're complying with different encryption standards. So let's talk about the different modes of encryption controls. You may remember that I talked about two modes. There's a monitor mode and there's an enforce mode. The reason we will discuss monitor mode before enforce mode is because you cannot directly move an existing VPC to enforce mode. And the reason is because what enforce mode does is enforce mode ensures that all your existing resources are enforcing encryption in transit. And it also ensures that all your future resources that you will ever launch in your VPC, they will also ensure encryption in transit. So, but in order to ensure encryption in transit for existing resources, you first need to identify what resources are not enforcing encryption today. And for that, you need to first turn on monitor mode. So turning on monitor mode is, as I promised in the previous slide, turning on monitor mode is very easy. You just select your VPC here, and then you just turn on encryption controls here. And you'll notice that the enforce mode is grayed out. It's grayed out for existing VPCs because you first need to make sure that all your resources are encrypting traffic at resource level. And this holds true only for existing VPCs. By the way, if you're creating a new VPC, you can always immediately turn on encryption enforcement because you don't have any resources there. So here, once you turn on the monitor mode, we give you a new control using which you can identify the resources that may not be enforcing encryption. So you can go into the console, VPC encryption controls console, and you will see that there are these resources which are not encrypting or which are not enforcing encryption today. You can also use the CLI to identify those resources. when you look into the screen, you will find out not only the resources that are not enforcing encryption, but you will also find out whether these resources are eligible for exclusion or not. So we'll discuss later in the slides how can you exclude certain resources. But by exclusion, what we mean is that there are certain resources. For example, there's internet gateway or virtual private gateway using which your traffic transmits outside the boundary of AWS. For such resources, you are responsible to enforce encryption. So either you can remove those resources from the VPC, or you can continue running them as exclusions. And when you continue running them as exclusions and you still go into enforce mode, what AWS will ensure is that all future resources or all existing resources except these excluded resources will enforce encryption. For these resources that are excluded, you are responsible for maintaining encryption. So this is what exclusion does. And once you identify these resources, we'll also discuss how to migrate each of these resources and how to make sure that they're enforcing encryption. But before we go there, the monitor mode also gives you the ability to monitor the encryption status of individual traffic flows. And you can do that using your familiar VPC flow logs. When you turn on VPC flow logs, we have introduced a new field here called encryption status. You can just turn on encryption status, and encryption status will start emitting numerical values to tell you whether your traffic is encrypted or not, or whether it is encrypted at the application layer or whether it is encrypted at the physical layer using Nitro encryption. So this is how you can read the encryption status. When the encryption status is 0, it means that the VPC encryption controls has recognized your traffic flow as unencrypted. Now, please note that VPC encryption controls recognizes the Nitro encryption at the physical layer as well as the application layer encryption only to AWS services via AWS private link interface endpoints and gateway endpoints. Now, when it emits a value of 1, it means that your traffic is encrypted at the physical layer using the Nitro system hardware. A value of 2 means it's encrypted at application layer. Again, you will see the value 2 when your traffic is going to or coming from AWS services which are accessed via gateway endpoints or interface endpoints. Now, the numerical 3 tells you that the traffic is encrypted both at the physical layer by Nitro and at the application layer. And if you don't get any value, it means that either you haven't turned on VPC encryption controls or flow logs currently does not have that value with it. So this is how you monitor the encryption status, and this is how you identify resources which are not enforcing encryption. Next, let's see how you can turn on or how you can move to transition your existing VPC to enforce mode. Again, just to repeat, if you have a new VPC, you can turn on enforce mode at creation itself. But for existing VPCs, you first need to turn on monitor mode and you need to identify the non-compliant resources. The non-compliant resources are the resources that are not enforcing encryption in transit themselves. Once you have done that, the next thing is that you need to make certain changes to these resources, and you need to ensure that all these resources are enforcing encryption. And you will see, and we'll discuss that in the subsequent slide, you will see that for many of the resources, we'll take care of encryption ourselves once you turn on the encryption controls, even in monitor mode. And then once you have made sure that your all resources, especially the non-excludable ones, are enforcing encryption in transit, that is when you can modify your encryption controls to turn on enforce mode, or you can transition to enforce mode. So let's look at how you can ensure that your different VPC resources are enforcing encryption. So for many of the resources such as Fargate task, application load balancer, network load balancer, the moment you turn on encryption controls in monitor mode itself, behind the scenes, we'll start migrating these resources onto new Nitro hardware so that they can automatically and natively support encryption in transit. So you don't have to do anything. Once you turn it on, we'll take care of it. It will take some time, but we'll do it. For all AWS services, except API gateway, for all AWS services that are supported by private link interface endpoint or from gateway endpoint, we'll enforce encryption at the application layer. And what this means is that if an application tries to send unencrypted traffic to such AWS services, we'll just drop it. Then there are a host of other services. These services, which is your EC2 or your auto scaling groups or EKS or ECS, etc. Here, typically you select the underlying instance type. So you are responsible for choosing the modern instances. For many customers that we have talked to, they're already using modern instances for these resources. And if you're doing that, you're all set. But in case you're using an older generation instance, you need to move those resources onto new hardware or onto new EC2 instances, the modern EC2 instances. Once you do that, they will also start encrypting traffic at the physical layer. And all these resources lie inside your VPC, and they help you enforce encryption within the VPC itself. Now, let's talk about what you need to do if you have a transit gateway and you also want to encrypt your traffic across VPCs. So for transit gateway, we have introduced a new option called encryption support. And you can turn it to enable. And once you turn it to enable, even your traffic between your VPCs that have encryption enforced will start getting encrypted at the physical layer itself. So now, once you've moved all these resources to encryption enforcement, you can then transition to enforce mode. While you're transitioning to enforce mode, the console will give you the list of resources that are unencrypted and will also give you the list of resources that are eligible for exclusion. You can turn on exclusion for those resources, and then you can turn on enforce mode. Once you turn on enforce mode, the VPC does two things. One, it makes sure that your existing resources always communicate in encrypted traffic. And the second thing it does is it makes sure that any future resources that you instantiate inside this VPC are always enforcing encryption. It won't allow you to launch older generation of EC2 instances which do not support encryption. So that is what enforce mode does. After turning on enforce mode, basically this allows you to enforce encryption within the VPC. But next we'll discuss how can you ensure encryption across VPCs using VPC pairing and transit gateway. So whenever you're using VPC pairing, suppose if you have two VPCs and both those VPCs have encryption controls turned on in enforce mode without any exclusion, you can pair these VPCs, and all communication between these VPCs will always be encrypted. However, even if one of those VPCs has any exclusions, or if one of those VPCs has encryption controls turned on in monitor mode or is turned off, then in order to turn on pairing with an encryption enforced VPC, you need to create an exclusion for that pairing. And what that means is that this VPC, the VPC on the left-hand side, this is going to encrypt all traffic except the traffic that's going to the peering connection. The traffic which is going to the peering connection, the encryption status of that traffic would depend on the resources that are communicating with each other. For example, if you have modern EC2 instances on both sides, or you have services that are running on top of modern EC2 instances, then this traffic will be encrypted. But in case if this resource tries to communicate with another resource that's running on an older generation of EC2 instance, then the traffic won't be encrypted. So this is how you can turn on encryption between your encryption enforced VPCs. But if you want more flexibility here, for example, if you want this VPC, which is encryption enforced, to be connected to a different VPC which is not encryption enforced, and still make sure that all traffic within this VPC is encrypted, that's when you need to use transit gateway. So this is what happens when you use transit gateway. You can turn on encryption controls on your transit gateway. When you enable encryption controls on your transit gateway and you peer to VPCs, what you can do is you can peer a VPC that has encryption controls running without in enforced mode without any exclusion, and you can pair it with a VPC which is not encryption enforced. And the solid line here represents the encrypted traffic, and the broken line represents the traffic that may or may not be encrypted. So in this case, what would happen is within this VPC, which is encryption enforced, all your traffic will be encrypted, even the traffic that's going to the transit gateway. Now the traffic is encrypted through the transit gateway attachment in your encryption unenforced VPC, and only the last leg of the traffic, which is between the transit gateway attachment and your resource in the unenforced encryption unenforced VPC, that will depend on the resource type that the transit gateway is communicating with. So this is how you can use this new feature, VPC encryption controls, to enforce encryption within your VPCs and across your VPCs. Next, I'll hand it over to Scott, who will discuss the different encryption strategies, and he'll talk about the emerging encryption frontiers. Thank you, everyone.
Thanks, Akshay. So let's talk about encryption strategies. We've all seen, or hopefully most of us have seen, the famous Werner Vogel shirt that Akshay and I are repping today. Encrypt everything, right? But encrypt everything is a goal, it's not a strategy. So how do we actually get to that goal? Encryption layering is the answer to this. And what I've found is that, interestingly, you can match encryption layering to the OSI model. If you're not familiar with the OSI model, it gives us 7 layers of networking. Some will say 8. I don't know who. Anyways, with 7 layers of networking from physical all the way to application. And what we find is that these different protocols work at different layers. So we have optical line encryption, or MACSec encryption, between our AWS secured facilities, like Akshay was talking about earlier. This exists without you having to do anything. You can also use MACSec encryption on your Direct Connect connections if you have a supported connection, right? You can check this in your Direct Connect connections and enable it. Then we can move up the stack into the network layer, that layer 3 kind of IP layer, right? And we get into AWS Nitro encryption that Akshay was talking about, which we can enforce using encryption controls and using modern instances. We also get some tunneling technology like IPSec, WireGuard, OpenVPN. You can find IPSec and OpenVPN in AWS Site-to-Site VPN and AWS Client VPN. And you can use these to encrypt between on-premise locations, various end-user locations, and your AWS VPC. Then we get TLS. TLS is really great, it's really performant. It encrypts kind of in that layer 4 through 6 area. Hard to really define where in there it is, so I just kind of left it for all of them, and we'll leave that debate for another day. And this is supported through your customer applications. Amazon VPC Lattice, if you're not familiar with it, there's some great sessions this week, go look at them. Elastic Load Balancer, CloudFront, and many more services support TLS. And then we get into application level encryption, things like SSH that exist out there. Client-side encryption, you may use something like our key management service, KMS, to do that. A lot of different ways to do that. But it really kind of moves up the stack, and using multiple layers is going to help you make sure that all of your traffic is encrypted, that you're really encrypting everything. So let's look at the characteristics of these different encryption protocols. So again, we have MACSec at the data link layer. Performance, really high. Typically this is implemented in hardware, right? With hardware acceleration ASICs or FPGAs that are doing the encryption at line rate. It's a hop-by-hop encryption though, right? That means that between every two-layer device or layer 2 devices, that's where the encryption stops, gets decrypted and then re-encrypted, right? So thinking of Direct Connect, between your on-premise router and the Direct Connect switch, it's going to be encrypted. Then it's going to get de-encrypted on that AWS switch. And then when we leave an AWS secured facility, we're again going to encrypt with optical line encryption or MACSec encryption, right? So it's that hop-by-hop characteristic, right? And we can manage this by the networking team typically, right? Then we get into IPSec. IPSec tends to be a little less performant, just dependent on where you're terminating it, right? If you have that hardware acceleration, it's great. One of the kind of downsides to IPSec though is that it's an encapsulation protocol, which means you're cutting off that maximum transmission unit, MTU. So over the internet or even over Direct Connect with AWS Site-to-Site VPN, you're gonna see an MTU somewhere in the neighborhood of 1433 bytes, maybe a little less, maybe a little more, just depending on what you're doing. But that's gonna be less, right? Which means when we start getting into higher latency environments, your performance is gonna go down, right? So you gotta really think about that usage there. But you can get some very performant connections as well. We actually just released 5 gigabit per second or up to 5 gigabit per second tunnels on AWS Site-to-Site VPN, which is really cool. I've been seeing the team work on this for a number of years. And this is a point-to-point connection, meaning that where you terminate the IPSec tunnel on each side is where it's gonna go. So it's spanning multiple hops, but it's not end-to-end. It's not from server to server necessarily. Could be, but not usually. Then we get into network encryption, right? Nitro. The security team can now control this using VPC encryption controls and setting those VPC encryption controls, right? So now we've taken things from the networking team and given some capability to the security team to enforce encryption. This is again point to point. It's going to be from an AWS EC2 instance to an AWS EC2 instance, right? So if there's multiple hops in there, like transit gateway, there will be some points in there where it decrypts and re-encrypts, so on and so forth. TLS, right? This is super performant, right? Because every individual session gets encrypted with a different key, gets hashed against multiple processing cores. Just an absolutely performant protocol. Honestly, most things today should be using TLS, right? Most of your applications. But it's hard to manage and hard to enforce because it's on the application owner typically to enforce this, right? So you really got to think through how you enforce this and how you audit it. And that's where multi-layer encryption comes into play, right? Because the networking team has an enforcement point, the security team has an enforcement point, and the application owner has an enforcement point, right? So everybody gets a little piece of the pie to make sure that we're getting fully encrypted. And then application layer encryption. This tends to be something like encrypting individual packets with something like KMS. And it's really hard to implement this in a performant way. If you want to be really, really super secure and try and do it, you definitely can. But for most things in transit, TLS, Nitro, some type of tunneling protocol, MACSec, optical line encryption, this is where you're going to get the most bang for your buck as compared to, kind of client-side encryption. KMS is better for more encryption at rest, right, than encryption in transit. So let's talk about emerging encryption frontiers, right? Akshay brought up earlier the history of encryption, and we've come a long way. And so we're now getting into post-quantum cryptography. And so everyone sees this and they think this magical thing, right? Quantum's all magic, right? No one really knows what it means. But post-quantum cryptography is all about the fact that in theory, there may be some future where a quantum computer could potentially break RSA or elliptical curve, right? There's not one that we know of in existence today that's done it. Not powerful enough. They haven't reached enough entanglement to be able to do that, enough qubits, right? But we think that maybe there's some future where that could exist. And before we get to that future, the industry as a whole has been studying how do we make encryption safe so that if someone's storing those packets, that they can't go decrypt them later, right? For most people, not really concerned, right? Because your data is probably not worth enough to store all that data forever. For some people, it's very important, right? Governments, financial services, other things like that, right? So it just depends on what you're doing, but it's one of those things that we're starting to think about, right? And AWS has started taking it really seriously. And we've started releasing services that support module lattice-based key encapsulation mechanism. It's a mouthful. So to explain what that is, right, we do a key exchange. And we use asymmetric encryption to do that key exchange using RSA or elliptical curve, and typically use Diffie-Hellman to do the key exchange, right, within that asymmetric path, right? Once we do that key exchange, we then get symmetric keys on both sides, and we use those symmetric keys as performant way to encrypt the data that's actually going across it, right? So we use asymmetric encryption to exchange symmetric keys, and then symmetric encryption to actually transport data. That's AES. AES, we believe, is quantum safe, especially 256, 128 evens. NIST has shown some data that it shows could be quantum safe. But RSA and elliptical curve is where the real concern is, right? And with perfect forwarding secrecy, even more so, AES is less a concern, right? Because we have different sessions in there. So we focused on ML-Chem within our services and how we do that key exchange. And we support it within KMS, Secrets Manager, Certificate Manager, CloudFront. We also just released, I believe last week, support for this in Elastic Load Balancer, or maybe 2 weeks ago. But Elastic Load Balancer supports it. So let's take a trip down history lane for a second. Think back to like early 2000s. Some of you probably don't want to think about the year 2000, some Y2K stuff there. Some of you maybe have no idea what I'm talking about. Don't worry, you can go Google it later. But if you wanted to support a new encryption protocol in your application stack in the early 2000s, that was a ton of work, right? There's a whole refactor, a whole infrastructure upgrade, just massive amount of work. With AWS, if you want to go support post-quantum cryptography with these services, in the console, it's a checkbox. In your CloudFormation, Terraform, Pulumi, OpenTofu, whatever else is out there these days, it's a line or two of code. That's it. That's all you got to do. And then you're post-quantum encrypted, right? As long as your client supports it, right? And you can support the multiple encryption protocols, right? So if your client doesn't support ML-Chem, then they use RSA or elliptical curve, right? And if your client supports ML-Chem, then they upgrade to ML-Chem and use that, right? And then as your clients become more modern, you can just enforce ML-Chem on these things with your TLS policies. So it's just really cool to think about that, of like how hard it was 20 years ago and how easy it is today. Quantum key distribution. Quantum key distribution is really, really cool because it's a way to prove through physics that when we exchange a key over this quantum network, an entangled network, that nobody saw that key exchange, right? So we use the Schrodinger principle, which says that when we do this key exchange, if there's someone in the middle, that state's going to change, it's going to flatten out. And then on the other side, we can see that someone observed that key exchange, and let's just not use that key because it's compromised, right? And we can prove it. It's a law of physics. You cannot break it. Really cool emerging technology. And AWS has been studying quantum key distribution for years. You can see down here a link from several years ago where we created a QKD network, or a quantum network over a couple of kilometers. And some other research is going on in that neighborhood. And so we're going to see this as an emerging technology in AWS. There's a really great session, INV 507, which if you get a chance, I suggest you go to. Just kind of cool thing to nerd out on, if you will. But it's a great topic to think about, right? Of like, what's next in that key exchange? How do we make sure that nobody can observe that key, right? So what's next? What do you do? How do we get to encrypt everything? Take these steps to get to a more secure future. Inventory your environment. inventory it through AWS config, through VPC encryption controls, right? Through Security Hub, all these tools that are available to you to inventory your environment, inventory your on-prem environment, understand what's being encrypted and what's not. Where is it being encrypted, right? What's being transmitted? Is it sensitive data, or is it something that honestly nobody cares if in plain text, right? Think about that, inventory it, audit it, right? Go through that inventory and understand what is important, what's meeting your requirements, right? Think through that. Start enforcing encryption. How do you enforce it? You gotta start having that conversation at the top, right? You gotta start talking to your CISOs, to your CIO, to even your CEO, and start having a conversation about, we need to take encryption seriously and we need to enforce it. In AWS, super easy, right? We have all these things that are just super easy ways to onboard to encryption. On-prem, maybe not so easy and maybe requires a little more investment, right? But start enforcing it. Remediate those things that are missing out in your audit, right? In your inventory and audit. And then repeat, because things change, right? Developer went and built some new cool thing, said, oh yeah, I'm not gonna use encryption because it's hard and it's just a dev environment. And of course, what happens to every dev environment in the world gets promoted to production, and oops, we forgot to encrypt it, right? So you gotta continuously go through this cycle. Continuously inventory, audit, enforce, remediate, repeat. With that, I'd like to thank you for coming to our session. I know that it was during the lunch hour and kind of the day before reInvent starts, so we really appreciate your time. If you enjoyed our session, go into your app, give us 5 stars and some feedback. If you didn't enjoy our session, go into the app, give us 5 stars. No, I'm just kidding. Give us some honest feedback. We love your feedback. And if you have any questions, Akshay and I will be right outside those doors across from the Content Hub right after this. We got to get out of here so we clear some space out, but we can meet you over there and answer any questions you have. Thank you.